In this video, I'd like to talk about the amplitude of sinusoidal functions from their equations. And remember that sinusoidal functions are either the sine function or the cosine function. And the amplitude of one of these functions is the distance from the midline to either the maximum point or from the midline to the minimum point, where that midline essentially cuts the sinusoidal function in half. And what we have graphed here, this is the sine of the independent variable, and we can say that this is the y-axis and this is either the x or the theta axis. Let's call it the x-axis. And this equation would then be y is equal to sine of x, where x is measuring the angle in radians. And we can see that for the parent function, the sine of x, that its amplitude is simply 1. The distance from this midline, which, by the way, the midline, let me use a darker color for that. The midline is y equals 0 for the parent function, but the amplitude, the distance from that midline to the maximum point is 1. And remember that the amplitude can also be measured from the midline point to the minimum. So it would be 1 here as well. And what I'd like to focus on in this video is essentially changing the amplitude by manipulating this equation. And if we want to get an amplitude of, let's say, 2, where now our function would come all the way up to a maximum of 2, go back through that midline of y equals 0, come down to a minimum at negative 2, and go back up. This is not drawn perfectly well, but we can get a general idea of what's happening here. And the way to approach this is that we essentially need to scale this function. We need to stretch it vertically. And we can do that in general if we have some function of x. If we want to scale this vertically, we multiply on the outside of the function by some coefficient here, some number a. And if we want to stretch this function, then a would have to be bigger than 1. And if we want to shrink the function or compress it, then a would have to be some type of fraction. And we can also consider what happens when a is a negative. When, let's say, a is less than 0, then this will cause a reflection. It will cause the graph to reflect over this midline value of y equals 0, and essentially all the y values will be negative. But for our function here, we're dealing with the sine of x. When we multiply that by a, just like with a general function, this will either stretch or compress or reflect this function about its midline. So if we want to find an amplitude of 2, we essentially need to multiply all of these y values by 2. Since if we focus on the maximum and minimum points, we want their y values to double. And if we multiply all the y values by 2, it would stretch the entire function up by that factor of 2. So the equation that we're looking for is simply y is equal to 2 multiplied by the sine of x. And by multiplying by 2 on the outside, like I mentioned, this would stretch the entire function up by that factor of 2. Essentially all the y values at every single point compared to this parent function would be double their previous value. And this would give us an amplitude of 2 here. And let me make a little bit of room. Now we also know that if we multiply our parent function by an a value that's a fraction, it will compress it, or it will shrink the function. So let's say we have y is equal to 1/2 the sine of x. This will multiply all the y values by 1/2. So now these Maximum values will be half of what they used to be, and same for the minimum values, they will now be half of what they used to be. So it will compress this function like so. And we will look at these using a graphing calculator in a moment. But this is just to get a general idea of what multiplying on the outside of this parent function, or really any parent function, actually does to the function. And lastly, if we multiply by a negative number, let's say we have y is equal to minus the sine of x, then this just reflects the entire function over the x-axis in this case, since the midline value is y equals 0. Essentially, every y value will now be the opposite of what it used to be. This y value will now be at positive 1. So it will become a mirror image across that midline value. And again, I'm not drawing this perfectly, but this is just to get a general idea of what this graph will look like. So now let's take a look at what actually happens when we have a computer draw this. And we can see here we're using the online graphing calculator Desmos, which is a free graphing calculator. And right now we have the sine of x plotted, but if I add in another equation here, we can look at y is equal to twice the sine of x, and we can see it essentially stretched the amplitude by that factor of 2. And whatever the number is out front, if we change that number to be higher and higher, it essentially just stretches that amplitude to a higher and higher number. Or in other words, whatever this number is, whatever we're multiplying the sine or the cosine function by, this will be our amplitude. And we can look at decimal values as well. Let's look at 3/10. We can see that it compresses the function, and now its amplitude, its maximum value will be at 0.3, and that's a distance of 0.3 from that midline. And like I mentioned, we can also look at the cosine function. It won't change anything except that our function will be shifted. But you can see the cosine is just like the sine function. It's just shifted pi over 2 radians. In fact, if we shift on the inside, we just get back that sine function. And the final case we want to consider is when this is negative. So let's go back to an amplitude that's bigger than 1, but let's make it negative, and we can see that it just reflects it over this x-axis, though it's also stretching it by that factor of 2. So the amplitude is 2 in this case, since it's just the distance from the midline to that maximum value, or from the midline to the minimum value. So the negative does not affect the amplitude. In fact, we can say that the amplitude is the absolute value of this number that we're multiplying by. So let's go back to our blackboard and we can generalize this. We can write more generally that y is equal to a multiplied by the sine of x, where this constant a, this is the amplitude of the sinusoidal function. It could be cosine as well. Though we need to be careful, because if a is a negative number, then the amplitude is really the absolute value of whatever that number is. Since in this case we had -1 for our a value, but its amplitude is actually positive 1. So whatever we're multiplying or scaling the sinusoidal function by, the absolute value of that number is the amplitude of the function.